Hey everyone, for my graphics project I built a real-time 3D Boid flocking simulation using OpenGL compute shaders on the Afterburner engine. The idea comes from Craig Reynolds' 1987 Boid's algorithm, where simple local rules create complex emergent group behavior, like schools of fish or flocks of birds. Each Boid follows just a few rules: separate from nearby neighbors to avoid crowding, align with the average heading of the group, and steer toward the group's center for cohesion. What makes this project interesting is that all of the flocking logic runs entirely on the GPU. I'm using an OpenGL 4.3 compute shader where every Boid is processed in parallel, one GPU thread per Boid. The position and velocity data lives in shader storage buffer objects using a double buffered ping-pong pattern. So the simulation reads from one buffer and writes to the other each frame, avoiding race conditions. On top of the three core flocking rules, I added several extensions. There's a boundary containment force with a soft quadratic ramp that keeps Boids inside a translucent aquarium sphere. Directional cohesion biases the pull toward neighbors ahead of each Boid, which gives the swarm a natural tadpole shape instead of a perfect sphere. Hash-based noise on the GPU adds organic edge fluctuation. There are 5 semi-transparent pillar obstacles placed throughout the aquarium. Boids avoid these, which forces the swarm to split and reform as it moves through the space. The predator, rendered as a larger red triangle, ignores the obstacles completely and plows right through. The predator uses a target locking strategy. It finds the Boid closest to the center of the swarm and locks on for about 5 seconds before picking a new target. This creates a purposeful hunting behavior. It dives into the heart of the flock rather than chasing stragglers. When it catches a Boid, that Boid is eaten and instantly respawns at a random location. Everything is rendered using instance drawing, one tetrahedron mesh drawn 1,000 times with the vertex shader reading each instance's position and velocity from the SSBO to orient it in the direction of travel. All parameters, flocking rates, radii, speeds, Boid count, are tunable in real time through an image GUI control panel, so you can experiment with different behaviors live. Thanks for watching.